Unit 5. We are taking a look at our learning targets that we have here. And the first check for understanding we're going to focus on is all by solving systems. Solve a system, solve a system, solve a system. Because that's what Unit 5 is. It's systems of linear equations and inequalities. Systems of linear equations and inequalities. So first thing, and we have a little bit of space down here. Before we get right into those notes, I want to start you off with just kind of really defining what a system of an equation is. And somebody said, hey, isn't this that stuff we did in our bell work? Anybody else think that? Okay, so usually on Thursdays, our bell work, number 7, had us solving some type of system. And I kept saying, we'll get there, we'll get there. And when you do, it'll be kind of like easy transition. So you kind of know what a system of equation is. A system of equations is when you graph two equations on the same coordinate plane. Okay. Well, you already know how to graph one equation, right? I gave you y equals 3x plus 5. You start at plus 5. You go up 3 over 1. Boom. 1 and done, right? So then, now I'm going to put 2 on the grid. And then the solution to a system. So the solution to a system is the ordered pair where the two lines intersect. And by ordered pair, I mean you have to have that x comma y. Every single one of your answers pretty much for this whole unit will be given as an ordered pair. Okay? Where do they meet? Because if we're solving a system, the only thing that solves the system is a point. Okay? So that's how we do that. So let's kind of go up here, and this is what we got our 2 colors for. So I'm going to kind of color code what I have here. So I'm just going to do my first equation in green, my second in pink, whatever colors you want to do. You could circle it, highlight it, okay? And this is kind of one of those where it's like, you probably would be okay, like doing this by yourself, because you're like, okay, I know how to plot 1, so now plot 2. Where do they touch? There are a couple little tips that I'm going to give you to make it a little easier for you, though. So let's take a look at this first one. Let's plot y equals 2x minus 3. So let's start at our y-intercept. So do you remember in Unit 4 when you had to, graph these, and that was the part of the check for understanding was just could you graph these? So remember if that was one you had a hard time on, because I need you to make sure you get that. So there's my plus 3, and then I'm going to go up 2 over 1. Okay, so now stop. Usually that's all you do. You put your y-intercept, and you put one other point, and then you sometimes don't even grab a ruler like me, right? You see me just kind of freehand it, and I don't even touch the points, okay? Well, if we're trying to find where these 2 lines intersect at the exact point, do you think it's a good idea to kind of just freehand it? No, because if I just freehand it and then freehand this, they may meet at a point on my graph that really isn't where they meet if I were to do it to precision, right? So the first tip as I'm going to give you is you have your y-intercept and then one other point. My advice is going to be make 5 points total, if possible. So I'm going to use this as my middle point, and I'm going to do 2 this way and 2 this way if I can. You'll see why. So I'm going to go up 2 over 1, up 2 over 1. Just put as many points as you can. And then to get this way, remember we would go down 2 and left 1. And then I'm going to draw my line. Okay, so go ahead and connect your points. Make sure your ruler's lined up nice. Okay. So I'm hoping that when I plot this, that it's going to land on one of my points that's already there. Okay, and if it doesn't, we'll have to talk about what happens. So plus 2, and then my slope is, when you have a whole number, your run is 1. So I'm going to go down 3, and boom, there we go. That worked out. So do I really need to do 5 points for this one? No, probably just for that first one. And this is an example of one of the easiest types, but I'm not done yet. Because just telling me or showing me with your graph is not going to be enough. I said that your answer needs to be an ordered pair. So here's the tricky part. Well, not for this one. This is a bad example. When you're doing slope, what is the direction? Don't you go rise and then run? When you go to get a point's name, though, what do you do first? You do it opposite, right? So the name of this point is +1, -1. So I had to go the opposite direction from I plotted my slope, and that can be tricky. You know how many times kids will have the graph right, but these two are flip-flopped? A lot. So be careful. Don't let that be you. +1, -1. Got it? Okay, let's take a look at number 2. So we'll do this first one green and pink. So go with me on this. I got a +1 right here. And sometimes the graph is not big enough for you to be able to fit more than the 1 or 2. So I'm going to go down 5 and over 3. And then just in case, I'm going to go up 5 and over 3. I know it goes to this point, but we can kind of guess that, right? So that's going to be my -5/3 x +1. And the chances are it's not going to be that point. They're not going to give you a grid that's only so big and then have it meet off the grid. So now when I go to plot this one, I'm at -3. And then these ones are all set up like so perfectly for you. Down 1 over 3. Boom. Okay? And that was all I needed for that one. Okay? So now I have to just give the name of that ordered pair. Be careful, it could be a little tricky. So from the origin, I'm going 3 to the right and then 4 down. So this is 3, -4. Good so far? All right. I really wish I would have changed this. Let's do this. Let's pretend like that x was not there. Let's just make this y equals 1, x equals 3. Okay? So let's just do, I'm going to change these up just to give you some more. You could even just scratch it out completely and rewrite it. So I have y equals 1, I have x equals 3. Here we go. Those are those horizontal and vertical that I keep getting confused. I can't remember which one's which. Why is it always on the axis? Somebody always thinks it's on the axis. So watch how we do this. The y equals 1 is this point right here, right? And then if you do that and you draw it vertical, that's not y equals 1. And that's x equals 0. So we're not going to even talk about that, but let's just do this. Every single y coordinate on this line is 1. 3, 1, 5, 1. So your y equals, let's make ourselves a little note here. Can't spell. Your y equals are going to be the horizontal. And here's a really easy way to remember your x. That looks like a V, doesn't it? If I take and reflect that, I get another V, and that reflected is an x. So I need you to know when it's x equals, it's vertical. And that's the only time you will ever have a vertical line is if it's x equals. Okay? So now, what does x equal? 3. So that's going to be my vertical. And now I need to give the name of this point right here. Be careful. Is it 1, 3 or 3, 1? 3, 1. Good. Okay? And then I want you to take off this minus 2. Just scratch that out for this one. So y equals x. Parent function. So in the parent function, y equals x, what is your y-intercept? 0. And what is your slope? 1 over 1. So let's plot this. And something weird, I'm hoping, is going to happen here because I changed that. I want it to do this on purpose. So you have a plus 1 here. And you have up 4 over 1. Let's get some more points down in this direction. So instead of going up and right, let's go down and left. So we have our first point, or our first line, rather. Okay. Now I'm anticipating this happen, which is why I changed it. Yeah. Y equals x starts here and goes up 1 over 1. Up 1 over 1. I don't need to keep putting points in this direction because it's not going to meet in that direction. Down 1 and left 1. So do you see the dilemma? What just happened? There isn't a nice pretty little point that they're going to meet at. So let's do this, and this is why maybe the thick markers is not the best idea. So now what we have to do is kind of zoom in on that. So I know it meets somewhere in this box, right? Do you agree it meets in the box? And we're not used to having points in the box. They're usually like at those intersections, right? Because we're good with that. So could you just say, well, it's kind of close to 0, 0. I'm just going to say it meets at 0, 0. No, it mathematically doesn't, because if it did, then one point would have fallen right on top of the second one, and it didn't. So when this happens, you have to give an approximate solution. Approximate solution means estimate. And here's what you have to be able to do. It goes back to your knowledge of number lines, right? So from here, I'm not even going all the way over to -1. So what I would do is this. I'm not going to be that picky. This is a couple millimeters wide here, and my pen is, thick. So I'm not going to say, oh, you had a third. I think it's more like 3/4. Nope, you're off. Sorry. My question is, are you in between the right two integers? And if you are, that's good enough for me. So my first guess would be -1/2, and then what would be another guess for that one? Another -1/2, right? Would that be okay? So I would guess a -1/2 to the left and a -1/2 down, okay? Let's just get more practice with that. What if this was, what if that was your point? So that would be 1, 2, 3. So it's in between 2 and 3. And for you overachievers, if 2.5 is not good enough, you could put 2 1/3, right? Because that actually looks like it's about a third of the way. So go ahead and you could put 2 1/3, and then put what you think would be a good y value. Down -1, -2, but it's not quite to -3, but it's pretty close. So what would be a good estimate there? 2 3/4, 2 8/9, if you think it's really close. I mean, do you see what I mean? You could totally and it's negative, right? So if that happens, you just got to kind of eyeball it. If you want to put a 1/2, great. I mean, if the squares are way bigger, then just be careful with that. Okay, so now let's flip to the back. Because there are always a couple special cases. Well, first of all, it's not what I need it to be in the right form. So I have to do what? Solve them for y. So let's go ahead and do that. And this kind of is unique. We've not ever had that before. Doesn't matter. So what? Get y by itself. So here's what might be a little helpful. Instead of subtracting x and adding 4, can we just get rid of the y and put the y over there? And move one thing instead of 2? So watch. Could I take 2y plus x minus 4 equals 0 and just subtract the 2y minus 2y? That leaves me with x minus 4 equals -2y. Do you see what I did? You have the freedom to do that. So what if the y is on the right? It's still going to get you your slope-intercept form, isn't it? So be careful of this. What is this slope? Not -2. It's -1/2. And my y-intercept is +2. Okay, I wouldn't graph it yet. And you'll see why in a minute. So this is so close to us being ready. I'm just going to divide by 2. And this is going to be y equals -1/2 x plus 2. Hey, it's the same thing. Right? So let's stop and think about this. If I were to graph this line and go -1/2 x in green or whatever, and then pick up my pink marker and do the same thing, it would be what? The exact same line. So if the question you're being asked is, where do these two lines intersect? Everywhere, right? Don't they intersect everywhere? But that's not a fancy enough answer, right? So what is their fancy answer in algebra for everywhere? All real numbers, or and in this case, we're actually going to say infinitely many solutions. Infinitely many solutions. Okay? So let's skip to number 30. I'm going to go kitty corner here, so let's skip to this. I'm going to do the same thing again. I'm just going to subtract 2y from both sides, and that's going to give me 4 plus 3x equals a -2y. Everybody okay with what I just did? I didn't feel like subtracting two things. So divide by -2, and y is equal to, this is going to be a -2 as our y-intercept, and our slope is going to be what? -1.5, but we're going to keep it 3/2 because it's just easier to do that. I kind of like that you're seeing these equations not in there, y equals mx plus p, all nice and perfect, because I need you to not freak out when that happens. So what? The y-intercept is -2, and my slope is -3/2. It's just in a little different order. Don't graph it. Let's do the next one. And this is going to give me y equals, what is this here? 8 divided by -2 is? And what's my slope? -3/2x. Yes. So I want to stop for a second and kind of go back up to this one up here. If you would have looked at these two equations and said, oh, the slope is -1/2, the slope is -1/2, oh, slopes that have the same or parallel, no solution. Well, this and this was the same line. So if they have the same slope and the same y-intercept, they're the same line. They're the same everything. If they have the same slope but a different y-intercept, then what's true about them? If you need to see, let's graph them. So let's graph this -2 down 3/2, or up 3 left 2. Now let's pick up our other marker, and I'm going to a whole different y-intercept. This time I'm going to -4. And because I don't have room to go down 3/2, don't make your grid like some people would make it all the way down here. No, just go up and left. 1, 2, 3, 1, 2. Did I do that? Okay, why is that not? Oh yeah, it's good. Didn't look like it. So what's true about these lines? Do they intersect everywhere? No, because they have different y-intercepts. So they have the same slope, but they have a different starting point. If the whole point of solving a solution for the system is where do they intersect, and they don't, your answer is no solution. Okay? So those are kind of your two special cases. So you have 3 possible answer choices. Four. Either they're going to meet at a nice, pretty little point, like this. Either they're going to meet, but not at a pretty little point, or either they're going to meet everywhere, or they're not going to meet anywhere. Do you see what your choices are? Okay? So, I will give you your sheet.